Hey everyone. Every single day, we're surrounded by this incredible power that we just command with the flip of a switch. But working silently right behind our walls are these invisible guardians, systems that are designed to keep all that power in check and, well, to keep us safe. So today, we're going to pull back the curtain on these unsung heroes inside your home.
I mean, we've all seen it, right? A frayed phone charger, maybe a little nick in a power cord. So, what is it that actually stops that tiny bit of damage from turning into a total disaster? That's the invisible safety net we're going to uncover. And look, the stakes are really, really high here. Electricity is, without a doubt, our most powerful servant. But if you let it get out of control, it can be an absolutely destructive master. The whole story of electrical safety is really just the story of how we learned to tame that power inside our own homes. And our story really begins with the original Guardian, a super simple but kinda ingenious invention that was designed to solve the very first big problem of bringing electricity into our houses. That problem has a name. It's called overcurrent. I want you to think of your home's wiring like a water pipe, okay? It's only designed to handle a certain amount of flow. Well, overcurrent is when the system tries to jam way too much electrical current through that pipe. Now, this can happen from an overload, plugging in too many powerful things at once, or from a short circuit, where a fault causes this sudden massive surge. Either way, the result is the same. The wires can overheat and start a fire. So, the solution was the fuse. And I just love this description, a sacrificial guardian. Its entire purpose in life is to be the weakest link in the chain. It is literally designed to fail first, to sacrifice itself, to save the rest of the circuit, and, maybe your whole house.
So how does it do it? It's beautifully simple. Inside every one of those fuses is a tiny little piece of wire, specifically designed to be a weak point. So when a dangerous surge of power hits, poof, that little wire melts in a fraction of a second. The circuit is broken, and the electricity just stops dead in its tracks. Simple, super effective, but it's got one big drawback. It's a one-time hero.
And yeah, that whole one-time hero thing, that drawback led to a pretty major innovation, the modern Guardian that doesn't need to be replaced.
And this is where the miniature circuit breaker, or MCB, comes in. Think of it like this. If a fuse is a disposable bodyguard, the MCB is a reusable security system. It's basically a really smart switch that senses the exact same dangerous overcurrents, but instead of melting, it just automatically trips to the off position, cutting the power.
And this slide just lays it out perfectly. I mean, look at the key differences here. A fuse is single use, and MCB is reusable. You have to go find and replace a blown fuse, but you just flip a breaker back on. And maybe most importantly for safety, MCBs react so much faster, and they make it totally obvious when they've tripped. It's a complete upgrade, which is why they're the standard in our homes today. So, okay, with MCBs, we've solved the problem of overcurrent and fire, right? Problem solved? Well, not entirely. There's another, kind of more insidious danger that an MCB by itself can't protect you from. A danger to you, personally. Yeah, this is the really crucial point. Fuses and MCBs, they're designed to protect the wiring and your appliances from, catching fire. But what protects you from getting a life-threatening electric shock if something goes wrong inside one of those appliances? Just picture your toaster for a second. If a wire inside somehow comes loose and it touches the metal case, the entire outside of that toaster becomes live with electricity. And without another safety system, it just sits there, waiting. The second you touch it, your body becomes the easiest path for that electricity to travel to the ground. And, well, that can be fatal.
This is where our third Guardian makes its grand entrance, the earth wire. This wire provides a super safe, really low resistance escape route for the electricity. So, instead of waiting for you to touch it, that fault current immediately rushes down the earth wire. And in doing so, it creates a massive surge, an overcurrent so big that it forces the MCB to trip instantly, cutting the power before you can even get hurt.
So that's what earthing or grounding, you'll hear it called both, really is. It's that physical safety connection to the planet itself. It's the critical link that turns a potentially lethal fault into nothing more than a harmless tripped breaker. It doesn't work on its own. It's part of a team, working with your MCB to protect you. Okay, so we've got our protectors against fire, and we've got our protectors against shock. But none of it, absolutely none of it, works without the foundation of the entire system.
And that foundation, it's the wiring itself. The wires and cables running through your walls are like the highways that carry all this electrical energy. And if those highways aren't big enough for the traffic, or if they're in bad shape, the entire safety system is compromised right from the start. So, to make this real, let's just use a concrete number. A typical household circuit in many parts of the world is rated for about 13 amps. That's the maximum safe flow of current that particular highway is designed to handle.
And this slide shows you exactly how that works in the real world. So let's say it's a cold day. You plug in a heater, that thing's pulling about 10 amps. Then you decide to do some vacuuming, that's another 5 amps. Well, as you can see, the total is now 15 amps, which is over that circuit's 13 amp speed limit. And what's the result? Click! The breaker does its job. It trips, and it protects the wires from overheating. So, the really crucial thing to get here is that these systems all have very different jobs. Fuses and their modern cousins, the MCBs, they exist to protect the circuit itself from overheating and causing a fire. Earthing, that's there specifically to protect you from a deadly shock. And the right wiring? Well, that's the fundamental bedrock that allows the other two systems to even do their jobs in the first place. You know, this whole network of guardians, it works silently, 24/7, without you ever even noticing, until it saves you. And that kind of brings us to the final thought I want to leave you with. Now that you actually understand how it all works, do you know where to find your own circuit breaker box? Just recognizing these silent guardians is the first step to really appreciating the incredible safety net that's built right into your home.